Welcome to the Logic Videos. I'm Scott Aiken. In this video, I'm going to be finishing off our presentation of truth functional connectives. In this video, I'll talk about the truth functional connectives of conditionals and biconditionals. Recall again that a truth functionally complex proposition is a proposition whose truth value is determined by the truth value of its component propositions. We've already looked at three of them: conjunction, disjunction, inclusive disjunction, and negation. We're going to look at two more, again, conditionals and biconditionals. Let's start with the idea of a conditional. So let's start with the claim. Let's imagine that we're sitting at a light, and I say to you, if you run that light, you're going to get a ticket. So I'm saying, if you run the light, then you'll get a ticket. So that proposition is truth functionally complex. You can have there's the running of the light, there's the you getting a ticket. Let's look at how those two component propositions influence the truth value of the overall proposition. So again, two T's, two F's for two values, and then you alternate with the other one. Okay, so far so good. Let's start at the top. So you run the light and you get a ticket. And what do I get to say? Told you so. So the if-then claim comes out as true. Let's imagine that you run the light, but then you don't get a ticket. My prediction is false. Okay, so far so good. Now, the next two are instances where you don't run the light. Okay? So, makes it a little bit harder to think of how we would think of the claim, the conditional, to be true. I want you to think along with me, however. So let's imagine that you don't run the light, but you nevertheless get the ticket because you had a busted tail light, or your registration on your license tag was out of date. Is what I said true? Now, for the purposes of this logic, just as we saw with inclusive disjunction, we have to make a decision. And the decision is going to be to treat the conditional as true. And the reason why is that, first off, there are going to be reasons why that are going to be revealed later in the syntax of the logic, and I'll make sure to show that, explain that to you. But the second reason why is that our defaults are going to be set on treating propositions as true to test them for validity. So right now, we're going to treat that one as true. The same thing goes with the next one. You don't run the light, and you don't get a ticket. In some ways, that's like you taking my advice and doing well by taking my advice. So, you don't run the light, and you don't get a ticket. We're still going to treat that as true. Now, these bottom two parts of the truth table for the conditional are a little controversial. We'll call that the truth values here at the bottom, the truth values of the material conditional. But for our purposes right now, you need to be treating those as though they're true. Okay? Now again, this is because of the fact that with logic, what we do is we treat propositions as they're true, as true whenever they're inputs, and then we'll sort it all out and all the rest of the reasoning later. But right now, we're going to treat those as true. So, now that we've got that, we've got we have a representation of the semantics of the truth functional features of the conditional. How are we going to represent it? We're going to represent it as with a horseshoe. And what's important is that little horseshoe, that little with the conditional, is that it, again, this says is semantically bound by this truth table, the truth table of the material conditional. Okay, so if claims go in the front part, then claims go over here. And again, you can kind of even see the activity, the motion of the conditional with the way that the horseshoe gets represented there. Okay, so now we've got one last one. And the last one has got a kind of unique feature to it, because it usually is, you might say, one of the ways that we kind of think of guarantees that we give to each other, one way that we think about how definitions work, and it's with what's sometimes called the biconditional. We say if and only if. So if I say something like A, if and only if B, So in this case, if I say something like, I'll wash the dishes if and only if you wash the car, right? So that's the claim, that's our promise, right? So let's imagine the first one. I'm washing the dishes if and only if you wash the car. They're supposed to be mutually guaranteeing things. And they're also supposed to be mutually disguaranteeing things. That if one fails, the other one fails. And if one is, the other one is. So if I've washed the dishes, then if we've kept our promise, then you've washed the car. So that comes out as true. But if I wash the dishes and you don't wash the car, then our promise to each other comes out to be false. And if you've washed the car but I didn't wash the dishes, then our promise to each other has come out as false. Notice finally that if neither of us do the things that we promised, then, ironically enough, what we promised to each other is true. Namely that I will wash the dishes only if you wash the car. You didn't wash the car, so I'm not washing the dishes. Or you wash the dishes only if you wash the car only if I wash the dishes. I didn't wash the dishes, you didn't wash the car. Strangely enough, because these two are both mutually guaranteeing and also mutually disqualifying, the tops and the bottom of a biconditional match. Why? Because these are supposed to be matching, because the truth values match. If the truth values don't match, all bets are off on biconditionals. So, and that's what makes biconditionals so interesting, is that they're mutually guaranteeing or mutually disqualifying propositions. How do we represent that? With what's called the triple bar. Once we've got these 5 in place, now we can start being able to start representing how we start thinking through the values of the component propositions, giving you a value on the component of the overall complex proposition, and once we're able to see that, we can start seeing some magic starting to emerge between those propositions in arguments. Next video, we'll be talking about how those computations work out.